When a scent molecule binds to a receptor in your nose, it triggers an immediate cascade, an energy flash propagating directly into your central nervous system. For millennia, people have used essential oils to manage their psychological and physical well-being, with historical applications tracing all the way back to the cosmetic rituals of ancient Egypt. Recently, researchers have moved past these holistic traditions towards systematic, controlled observation. This is aromacology, the study of how odors exert a scientifically observable influence on human emotions, moods, and behavior. Controlled studies in this field reveal specific, repeatable outcomes. Exposing participants to jasmine enhances problem-solving skills and task motivation. Inhaling nutmeg oil has been shown to reduce stress-related high blood pressure. The consistency of these shifts suggests that scent operates on a different plane of speed than conscious thought. These odors modulate our internal state and dictate physical responses before we have even put a name to the scent. The reason for this speed is anatomical. Every other sense you possess, vision, hearing, touch, routes through the brain's thalamus for initial processing. Smell bypasses this filter, taking a direct, monosynaptic pathway straight from the olfactory bulb to the primary olfactory cortex. Roughly 1/3 of this primary olfactory cortex is embedded within the amygdala itself. Traditionally, the amygdala is understood as a center for fear, emotion, and implicit learning, a system for coloring our experiences with feeling. But a simple emotional wash cannot explain the highly specific physical outputs we see in aromacology. It does not explain how peppermint oil increases athletic output, resulting in more push-ups and faster running speeds. By analyzing whole brain resting state fMRI data, neuroscientists have found that this region is not a single unit. It is actually fractured into 3 highly specialized routing networks. The amygdala functions as an active biological router. It sorts incoming chemical data and dispatches it into distinct motor, reward, and cognitive circuits. To map how the brain routes these scents, researchers analyzed functional connectivity using unbiased k-means clustering on fMRI data. This algorithm ignores traditional anatomical maps and instead groups brain regions based purely on which areas fire together while the brain is at rest. When applied to the olfactory amygdala, the connectivity data clustered into these 3 distinct zones. These zones correspond to the medial amygdala, the cortical amygdala, and the periamygdaloid complex. Each of these subregions exhibits completely independent connectivity patterns with the rest of the brain. Because this functional topology matches the anatomical boundaries, the olfactory amygdala is proven to be a collection of separate specialized processing hubs. This model isolates the medial amygdala, or MEA. It projects its own unique network outward. It wires directly into the posterior hypothalamus, an area critical for rapid neuroendocrine responses. It maintains extensive connections to the motor cortex and the basal ganglia, all areas involved in motor planning and movement. Finally, it reaches deep into the brainstem to connect with the raphe nuclei. This specific neural circuit is biologically optimized for the generation of rapid motor responses and autonomic fight or flight adjustments. This explains how a threatening or arousing odor triggers immediate physical locomotion. It moves from the nose to the motor cortex in a single routing. The medial amygdala serves as the brain's rapid response survival switch, translating chemical data directly into physical action. The cortical amygdala, or COA, utilizes an entirely different outward network. It connects to the substantia nigra, a core component of the midbrain's reward and value coding circuitry. It projects to the periaqueductal gray, which governs respiratory control and defensive behaviors, and it maintains strong links to the posterior hippocampus, linking the signal to memory formation. This network handles associative learning, approach avoidance conditioning, and reward processing. This governs your learned physiological responses to scent, dictating whether you involuntarily hold your breath in disgust or lean in to investigate a pleasant aroma. The cortical amygdala is the evaluator, assigning reward value to specific scents and dictating our future behavior based on past experience. Finally, we have the periamygdaloid complex, or PAC. Its unique connectivity focuses on processing complex social concepts. It maps strongly to the anterior olfactory nucleus and the orbitofrontal cortex, areas used for abstract object coding. It links with the temporal pole, a key region for social and emotional processing, and it maintains a distinct connection to the fusiform gyrus, the brain's specialized area for facial recognition. This architecture allows the PAC to act as a multi-sensory integrator, blending incoming chemical data with visual and auditory inputs. This facilitates complex behaviors, allowing your brain to neurologically bind a person's unique scent to their facial identity and their emotional state. The PAC is the contextualizer, weaving olfactory data into our conscious perception of people and objects. Despite this functional segregation, these three regions do not operate in isolation. A baseline network common to all three subregions connects them back to the hippocampus, the piriform cortex, and the entorhinal cortex. This establishes a unified physiological context for odor processing, before the signals splinter into their specialized routes. This shared architecture allows the brain to maintain a cohesive memory of an odor while simultaneously triggering multiple separate behavioral responses. This explains the diverse behaviors measured in aromacology. A single chemical compound enters this neural gateway, only to fracture into three simultaneous streams. When you inhale a scent like peppermint, the data routes through the MIA to physically improve athletic motor performance, while moving through the PAC and CA to alter your mood and focus. Odors do not just make us feel, they prep muscle fibers, activate dopamine release, and access facial memories simultaneously. We can no longer view the human amygdala as a monolithic emotional black box. The anterior medial amygdala is a highly segregated machine, dedicated to translating our chemical environment directly into complex human behavior.